All right. Now, for part two of our lecture, now that we know how Regex works and we got a little bit of practical application as far as how to implement Regex, we can apply this process of text removal and text analyzation to actually create a bot that works similarly to Eliza or similarly to a customer service bot, right? Whenever we go online, we want to pay a bill, we end up talking to some sort of chatbot. Now, the only difference is rather than creating this chatbot inside of let's say a telephone, we're going to create it on a terminal-based program. And when we create it inside of this terminal-based program, just keep in mind all that would happen is the difference between the terminal and actually talking to a bot would be I would be on the phone and there would be some sort of algorithm working to turning my words into actual text and then feeding them through the bot. And that's what's actually happening whenever you go ahead and call some sort of chat bot, you call your bank. When you're speaking, your words are being turned into text, fed through the bot in the exact process that we're going to work through here with regex, and then an answer is being returned to you. Right now, that text answer is being read by some sort of other mechanism that they have for reading text. So let's dive into this. We're going to do a bill payment chatbot. The bill payment chatbot should have the following methods. A conversation method. We should be able to identify exit and negative responses. Excuse me. We'll build methods for checking negativity and checking the exit command. We'll then handle a conversation method, identify intent, and we'll go through the process of matching a response. All right. The call method is something new that we haven't seen in the past, so we'll cover that today as well. So let's start off with our chatbot. Our chatbot should be able to speak to a person. All right, and it should be able to walk them through the process of being able to pay a bill. Now, we're not going to go through the entire process of building the, hey, here's your bill, give me your account number, but we are going to go through the process of analyzing intent by empowered through regex. And then we'll go through the process of matching them to the correct action. So we'll start off by actually creating our class here. So I'm going to create a class. This one's going to be my bill pay bot. It looks like I'm getting a little bit of interaction here. Let me go ahead and put this guy back to sleep. All right. And in here, I'm just going to simply start like any regular OP. I have my init method. And my init method should take in self. And finally, I should have a conversation. So I'll just go ahead and have a greeting here. Now make that equal to some sort of f string. Let's just do, hello, my name is Billbot. I am here to help manage your account. How may I be of service? And then we can finally do, you can say things like, pay my bill, or check account balance. All right, so there's my greeting. I have my bot, and finally I can make a conversation. So I can do conversation, which is a method that belongs to an instance of the bot. So I'm still going to utilize self. All right, and in this method, I'll go ahead and ask for the reply of a user. I'm going to set that equal to my input, where I'll pass in the greeting. And then finally, I'll go ahead and print the user's reply. So this is all just step one. All right, so we go ahead and send that. That looks like it worked perfectly fine. Let's call the bill pay bot. So we'll do bot equal to bill pay bot. And finally, I'll do bot.conversation. Okay, so here I say, hello, my name is BillBot. I'm here to help manage your account. How may I be of service? You can say things like pay bill or check account balance. All right, I want to check my account balance. I press enter and I can see that check my account balance is returned to me. I'm actually going to turn this into bigger screen. We're not really going to need our drawing here. All right, and there's BillBot. Currently existing. We have our conversation method. Nothing too crazy so far. All right. Well, now that we've specified a conversation method, we want to take that input and check if there's any sort of negative responses. What could a negative response be? All right, let's hear it, Rick.
It could be just as simple as no or cancel, or something that the user would type in to try to exit or cancel an interaction, like no, cancel, mm, exit.
Okay, let's leave it with maybe no, cancel, and we could probably add a couple of other things like not now or never.
Yeah.
Let's do not now and never. Okay, so self dot negative responses. Okay, and we could also add something like self dot exit commands. Right, well, these exit commands could be something like, hey, I want to exit, or I want to quit, or as simple as bye. Right, we also have the get out, or let's go ahead and do leave me alone in there. All right, so there's a couple of different exit commands that we have available to us. Now, why are we establishing what a positive or a negative, or what a negative command and a exit command may look like? What would that do for us? Let's hear it, Rick.
uh, what we just got done doing. So searching for those words in the customer's response.
Yeah, we could look for those words inside of the customer's response. And if so, we can actually just say, all right, well, we'll leave you alone, right? So let's create a couple of methods that would do that for us. So let's do a check, a negative response, which will take in self and the user input. All right. Now, once we have our self and the user input, we can actually check if this information is inside our user input. Now, I could utilize regex to search for it. I can say, hey, I could turn all of these into regex patterns. So I could say, hey, here's my negative responses. Boom, boom. Add an R into all of them so that they're all regex. And I can just state, should probably import RE. That looks important. All right, and I can say found be equal to re.search, where essentially we are looking for, and we'll iterate through each one of the responses. All right, so I can say for negative and self.negative responses. re.search, where we can pass in the negative expression and then the user input. Let me go ahead and pass this here, where this would be a string. And what we want to return would be a Boolean. Okay, so now we can say if found, or we can do returned true, if found, else false. Now I'm doing this specific portion here. Oh, and actually, that wouldn't work. I would just say if found, return true. And outside of the loop, I would put to return false. All right. Now, this check negative response essentially states we're going to iterate through all of the negative regexes or regular expression. We're going to search for them to be inside of the user input. If at any point we have a match, we'll go ahead and return true. Okay, great. Well, let's just go ahead and do a print statement here. And let's just redirect the print statement to stay print. All right. I understand you don't want this action. Let's try again later. All right. Now we can implement this check negative response portion. Let's say self.check negative and pass in the reply from the user. We can state if self.check negative. Well, we can move on later on as to what to do if it actually prints out negative. Well, let's try it out. Okay, so hey, I am BillBot. No. All right, bot conversation raised an error, and it did it inside of negative reply. For negative and self.negative responses, bill payment object has no attribute named negative responses. Interesting. Let me make sure that that is right. Oh, negative responses. Interesting. All right, we do know. Okay, so that runs through and it tells me, all right, I understand. You don't want this action. Let's try again later. So now through regex, rather than going through and iterating through each one of the letters and trying to figure out if there's a match with a double equal sign, I'm able to leverage all the regex patterns that I've created to be able to identify this information. All right, now I'm going to do the same thing for my quitting patterns. So I can just go ahead and add an R to all of them as well. All right, so check negative and check exit. It's going to look very much the same. We'll do check exit, where we're going to take in self, the user input, which will be of a string, and we'll pass in bool. Then we'll ask for exit in, let's do exit command in self dot exit commands. Found is equal to re.search, where we'll go ahead and practice each exit command and search it within the user input. If found, we will simply return true and state print. Thank you for coming in. I hope you are satisfied with your service. And finally, we can just return false. Now, how do we actually apply this inside of this conversation? Well, inside of this conversation, we can say if check negative, we can just return, but we'll do that later on. But what we can do here is say if self dot exit commands, or excuse me, check exit, we pass in the reply, we can simply break out of this loop. And we can even pass in something like while true, indent all of this, and then rather than printing the reply, we just continue moving through it, right? Well, let's see what happens when I run my bot this time. Yeah, I run my bot. Hello, my name's BillBot. No. All right. Hello, my name's BillBot. It doesn't seem to have given me my actual print statement, and that's okay. It's just the way Jupyter Notebook works. Now I'm just going to run exit. Okay, it kills my application. I see that I got the print statement saying, all right, I understand you don't want this action. Let's try again later. And thank you for coming in. I hope you're satisfied with your service. So far my BillBot is coming pretty well together. It's able to have a conversation with me, and it's able to recognize both exit and negative commands. Again, the conversation is running in a while loop, taking in the user input. We are then running a negative recognition to see if whatever they're stating is a negative command. So we could probably utilize this later on once we're within some sort of, do you want to pay this bill or do you, et cetera, et cetera. Then we could actually have a negative response be identified. So we'll use that later on. And then we have our exit commands, which actually allow us to exit from the conversation that we're having with our BillBot. All right. We've covered quite a bit of code, so I want to go ahead and pause here and open up for questions. Does anyone have any questions over the material that we covered up to this point? All right, let's hear it, AJ.
Okay, so it's not directly related to this, but it's something that's been like I've had trouble with wrapping my head around. Like, when is it obvious or appropriate to indent things? Like sometimes I don't understand why we indent things like print return, but the other return statements further back. So it's more of a general thing. I apologize.
No, no problem at all. So in this case, the reason why this return statement's all the way on the outside is because if I were to place the return statement indented inside of this for loop, then within the first iteration, it could kill my for loop. All right. I don't want it to do that. I want it to go through the entire list of negative responses. And if once it finishes iterating through the entire list, it's not able to find a match, then I want it to return false. But if I were to place this return and indent it, then it would only go through the very first index of negative responses. Does that make sense, AJ?
I think so.
All right, awesome. Okay, fantastic. So far we have our build bot. It's working pretty well. It's currently it's not going to return anything, so let me go ahead and annotate that there. Now let's go ahead and continue moving forward with our build bot by developing a handling the conversation method. Because right now, if I start putting all the logic inside of the conversation, this might get too hectic. So instead, I just simply want to create a method named handle conversation. Now, this handle conversation method is going to be an instance method, and it's going to take in the user input, which we know is a string. And as well, it's going to return none. I'm going to take out this while loop portion, place it inside of the handle conversation, because at this point, the conversation has been initiated. I'm going to ask for my initial reply. Take all of this out. And move it down to my handle conversation. And then I'll just pass in the reply to the handle conversation. So I'll say self dot handle conversation and pass in the reply. Both of these should now just be named user input. So a little bit of restructuring. Nothing has really changed fundamentally just yet. If I go ahead and play this, expected none, handle conversation, boom. All right, if I go ahead and execute this and I come down to the bottom, it's going to ask me for some information. I put no. It seems to be stuck in some sort of infinite loop. Let me check here as to what's going on. All right. Handle conversation, while true, self.check, negative input. Okay, I see. So it's happening over and over again because it's while true. And then passing it straight into that negative input. So I'll just go ahead and ask for a reply at the end of this while true state. I'll just say user input is equal to, pass it an input, and ask how else may I help? And then pass in that \n. So we go to execute this again. Okay, I pass in no. We see, all right, I understand. How else may I help you? I would like to exit. Thank you for coming in. I hope you are satisfied with your service. All right. So there's our handle conversation method mutating a little bit. We can see it being developed, becoming a little bit more dynamic. We have our ability to exit already. But now we can go into the nitty-gritty thing of identifying intent. Now for identifying intent, I'm going to write this method out here. Now, this intent should have the following. We should be able to pay a bill. We should also be able to check a balance. And we should be able to ask for general help from the application. Now, whenever we're applying these, we don't want to do an entire algorithm that searches through them. Right, so let's do a little bit of pseudocoding as to how we could do this. We want to take in the user input. From taking in the user input, I want to run a regex that would match an intent. And then I want to simply return the intent that was matched. All right. Well, now how would that look? I would simply create a method called identify intent that would take in self and the user input. While I'm identifying intents, I could probably set an attribute named intents, where these intents would be something like, hey, I want to pay a bill. And it could have a list of regex strings. So let me go ahead and add here where the key is equal to intent. And the values are equal to a list of regex that match the intent. Okay, I also may be able to check my balance. And I should be able to ask for help. All right, so what kind of regexes would allow me to find something like for paying a bill? Can anyone think of anything?
Payment, make payment, pay bill,
Okay, so
pay.
make payment, pay bill. It sounds like the underground, the verb that we want to isolate is pay. All right, so we want to isolate the verb of pay. Okay, and what would be the noun that we want to isolate in this case?
Bill.
Bill, nice. But not only do we want to identify each one of these alone, we also want them to be identified within the same regex. So maybe we have something like pay bill, or in the off chance, maybe they say something like bill payment. So I should be able to account for them to be backwards as well. Okay, well, both of these are going to be regex expressions. But then comes the fact of how do we actually set up this regex expression? How do I know that they're actually saying, hey, I want to pay my bill, or I want a bill payment? Well, we know that at some point this is going to come, we want it to come first. And we actually didn't cover this flag, but we'll do the \B flag. And in this \B, we'll simply identify the word pay. We'll say \B. So that means anywhere within the first segment of the string, we want to find pay. Now, after pay, we're going to do wildcard because there may be something like payment, something like pay more, etc. Point is, we don't really care what they say after pay. I want to figure out what it is that they want to pay. And in this case, well, I want to isolate that what they're trying to pay is their bill. There may be many characters afterwards. There may be many characters before. There also may be many characters in between them. But I am analyzing that they are paying their bill. And I can apply the same regex here. 0 or none. For me to identify that they are paying their bill. Now, this \B also accounts for uppercase letters or lowercase letters, so we don't have to worry about, hey, I want to change this back and forth. Now, this check balance portion, when it comes to balance, there's really nothing else that they're allowed to do other than just checking their balance. I could do the same process of, say, check balance or balance check, right? But ideally, I just want to see that there is a regex that at some point states balance. If anywhere within that regex I find balance, then it's going to execute this portion. Now notice how they're isolated to each one. So whichever one comes first will be the one that it matches. If I say, I want to pay my bill and check my balance, the first thing it's going to notice is, oh, you want to pay your bill? That's what we'll execute. We'll pay your bill. And then finally, I have my regex for help. All right. Does anyone have any questions about these intents? Awesome. in that case, let's go ahead and start moving through our input here. I'm gonna take my user input and I'm just gonna flatten it. And then finally, I'll go ahead and say for intent, comma expressions in intents dot items. Now this intents dot items, remember, it's going to simply return what I'm iterating through is now a list of key value pairs. Where the key is the intent and the value is the regular expressions that would match that intent. Now I can iterate through the different expressions. So I'll say for reg in expressions and match it. If re.search expression, or excuse me, reg in the user input, then I want to simply return intent. If nothing is triggered, I can return an underscore. And there's my ability to identify intent, where that underscore would just be, sorry, I couldn't understand you. And we go through the process again. All right, so let's check this process here. Or shoot, we could even handle that in here. So we could say print, say, sorry, I couldn't understand you. Please clearly state pay bill. Check balance. Or help. Oh, I could figure this out. There it is. And instead of turning this to a print statement, I could turn this into user input is equal to input, add our \n there towards the end. And instead of returning, I'll just utilize recursion to call self dot identify, or in this case, because we're not within a class, I'll just say identify intent. That passes in the user input. All right. Well, let's apply this now. I'm gonna highlight this portion. Come up to my chatbot here. I'll say self.intents be equal to. And there are all of my intents that I declared earlier. I can now grab my identify intent and bring it up above. I'm going to check a little bit of syntax here. So user input, that takes the lowers. This would be self.intents.items. It's going to return the intent. Otherwise, it's going to return self.identify user input. All right. Now let's go ahead and apply this inside of our commands here. We can also now utilize this self.check negative input as well if we wanted to. But for now, I'm just going to simply say I want to self.identify, I'll say intent be equal to self.identify intent, and pass in the user input. And we'll just simply print intent. Let's go ahead and run this script here. Let me scroll to the bottom. So hello, my name is BillBot. I am here to help manage your account. Okay, I can go ahead and say I want to, let's say I put in gibberish. Sorry, I couldn't understand you. Please clearly state pay bill, check balance, or help. Well, I want help. Okay, so I see that help is returned as my intent. How else may I help you? I want to pay my bill. I see pay bill has been returned as my intent. And finally, I want to check my account balance. And check balance gets returned as my intent. If I say exit, again, thank you for coming in. I hope you're satisfied with your service. All right, so quite a bit of information that we've been adding here. We can change this to state that this is going to return a string and that it's actually going to take in a string itself for the user input. But now we have the ability to identify intent. Does anyone have any questions about how we were able to identify intent? All right, let me do a quick recap over everything we've done here. So far, we've created our BillBot class, which has a greeting. We have a series of negative responses, exit commands, and intents. Intents being a dictionary where the key is the intent value, and the value is going to be a series of regexes that match the intent. We have our conversation method, which begins the conversation and takes in the input, passes it over to the handle conversation method. The handle conversation method then starts the iterative process where we're checking for exit commands. If there is an exit command, we're going to simply exit our chatbot. If there isn't an exit command, we dive into our identify intent, where our identify intent basically just tries to figure out if we're trying to pay our bill, check our balance, or just genuinely asking for help. If none of those are triggered, we state, sorry, I can't understand you. These are your options. And then we send that user input back again in recursion. We have a check exit commands method, which essentially just matches that regex. And if it finds an exit command, it kills our program. At this point, does anyone have any questions over BillBot? Let's hear it, Rick.
More of a comment, but looking around on the Python libraries, you can actually download. A lot of people have made natural language processing sets you can actually download and use in your code and libraries. I thought that was pretty interesting.
Yeah, awesome. Yeah, we're definitely going to go and dive into that stuff here later on. We utilize scikit-learn, which is very popular in the data science community. All right, now let's dive into our last method here, which is going to be actually matching that intent to a response. So here I have my identify intent method. My matching will be pretty straightforward here. I'll just say def. I can say match response to an intent, which would take in self and intent that we know is a string. We have some options there. And what this is going to return is none for now. Ideally, it would return some sort of other class that would handle the process of actually paying a bill or checking the balance. But for simplicity's sake of today's class, this is where we're going to stop with our chatbot. So I'm simply going to state if intent is equal to pay bill, then I want to print. Great. Let's pay your bill. Please provide your 10-digit account number. All right, else if intent is equal to, and in this case, we're going to go ahead and state check balance. Say print. Your current balance that's a credit card number here. Your current balance is as follows. And then finally, else, which the only other thing is help. We'll go ahead and print. I am capable of helping you make a payment and or here your account balance. And I could just say any other actions would require you to visit us in person. All right, so there's my 3 different statements here. I could match my response. At that point, I can go into my handle conversation. I'm able to capture my intent. And I can just say self dot match response and pass in the intent. Now, in this intent portion, we can probably use our negative commands. So I can come up here for identify intent. I can say if self dot check negative I can just return. Oh, and check negative actually takes in the user input itself. I can simply return an underscore. Turn this into an else if. Or I could handle it in here actually. I'll say if intent is not equal to an underscore, then we'll match the response. Otherwise, we'll just ask, how may I help you? Okay, let's go ahead and run our chatbot now. Okay, they don't like that triple equals because that is in JavaScript, not in Python. So let me go ahead and fix that here.
You also left a colon off the if statement.
Colon off the statement. Let me see. Boom. Thank you. All right, so we can execute. This tells me, hey, my name is Billbot, etc., etc. Type in a bunch of gibberish. Sorry, I couldn't understand you. Yeah, I need some help. How else may I help you? And I see that any other actions would require you to be coming in. Okay, I can type in gibberish. Sorry, I can't understand you. I can say no. And I get the, all right, I understand you don't want this action. Let's try again later. How else may I help you? And now I can state, I just want to go ahead and pay my bill. Please provide your 10-digit account number. I want to check my balance. If I go to check my balance, I get your current balance is as follows. And finally, I could say goodbye. Or let's just go with bye. Thank you for coming in. I hope you're satisfied with your service. All right. So we're able to identify intent, and then we're able to match that said intent with a specific action. Again, ideally here, we would utilize composition, where we would call a separate class, or you could make a method if you would like. Ideally, you would utilize a different class that would handle payment or bill payment. Here, you could have a method that would just return the account balance. And this else statement, I think this print statement works for else statement in this case. Or you could have another composition class that will connect customer service and handle the process of connecting to the customer service. All right. Now, currently, we're calling the bot conversation. But instead of calling the bot conversation, I want to integrate something called the call method. Now, the call method just allows me to execute a specific portion of code and how to execute it. So I can just say self.conversation. That way, when I call the bot, I can actually execute the bot itself. So this syntax here, or excuse me, let me clarify. This creates an instance of the class under bot, and this utilizes the call method for the bot, which starts our conversation. You'll see that nothing changes. Everything runs exactly the same. Sorry, I couldn't understand you. I need some help. Pay my bill. I want to see if there's balance, and I want to exit. And just like that, we utilize regex, a couple of different methods, and a lot of OOP principles to be able to create a bill payment bot. At this point, does anyone have any questions over how we created our bill payment bot and how regex is a vital part of being able to really leverage all of this text parsing and text cleanup to ensure that we're able to match intent to specific actions? Let's hear it, Rick.
Yeah, so this is just like a rudimentary chat bot. This isn't really how AI works under the hood, or
So a good example of what we just made here would be Eliza. All right, so if we go over to Eliza, right, oh, there you go. Eliza would work exactly the same way as what we just made. So I come over to Eliza, I say, how are you doing? There's some sort of regex that would specify, hey, he's asking a question, and the return would be, why do you ask? For example, if I say, where are you? I see, why are you interested in where I am? So there's a couple of, they're probably identifying how and where through some sort of regex pattern to be able to return these responses. But Eliza is essentially what we just built here for a bill payment method. Does that answer your question, Rick? Okay, I heard yeah. Awesome. Any other questions? If you're speaking, Rick, I can't hear you. Okay.
no, I'm good.
Awesome. It doesn't seem like there are any other questions. So let me go ahead and stop our recording here.